Hey guys, welcome. This is our 5-6 video. A lot of problems to work on, but pretty fast problems to work on, so let's get started. Alright, first one to write down, so again we're going to write this guy down. Today we're focusing on our central understanding here. The angles and sides of a triangle have a special relationship that involve inequality. So the way that we can actually form triangles has a lot of dependent variables, and we're going to take a look at those. So let's take a look. Our first corollary is a corollary to exterior angles theorem. So if you remember, this angle 1 is actually equal to the sum of these two. That was our old equation. Now what we're basically saying is we're just saying if angle 1 is an exterior angle, which angle 1 right here is, then it is larger than 2 by itself or 3 by itself. Well, this makes sense because our normal equation was angle 1 would be equal to angle 2 plus angle 3. So obviously angle 1 has to be bigger than 2 right there, and it has to be bigger than 3 individually. So that's all this is. Kind of a silly corollary, but we're going to go ahead and take a look at it. It's almost like common sense, so let's go ahead and move on. So make sure you write that one down. This one I think is really easy to explain. We'll still write this guy down. If two sides of a triangle are not congruent, then the larger angle lies on the opposite side. I love having my video screen here. Basically, if you look at my hand and I create an angle down here at the bottom, and you look at my two fingertips right here, so I'll kind of get my head out of the way. The distance between my two fingertips, as the angle gets larger, they get further away. So the largest angle is going to be across from the largest side. Okay, so if we know that this segment XZ is the longest side, it's going to be opposite the longest angle. That's all we're really saying here. So very kind of easy to understand. We have to add in a couple of things as long as they're not congruent. If they're congruent, then we can come up with some other things. But if we have generally the largest angle opposite the largest side, this is one of our theorems. Let's go ahead and get to one that's very similar to that. Whoops, went too far. And that's doing the vice versa. Across from the largest side, across from the largest side, we're going to have our largest angle. So this is kind of like the flip of it. The longest side lies opposite the larger angle. So we're kind of saying the same thing back and forth. So again, make sure you write this one down as well. So just take a second. We're going to utilize these in a moment. I think they make more sense when you actually utilize them. But so far we got 3 theorems written down. We got one last one. I know. Theorem heavy, right? Alright, here's our last one. This one is huge. This one is a giant one. It's called our triangle inequality theorem. This one's great. Again, we're writing it down. The sum of the lengths of any two sides of a triangle is greater than the length of the third. The easiest way to do this, if this isn't true, then it's not a triangle. Okay? So this will always hold true for every single triangle. So, if not, then we're kind of in trouble. So let's go ahead and let's take a look at our first couple problems. So here we go. Jumping into it. Again, you wrote down 4 theorems so far. Let's go ahead and apply some of these. Alright, here we are. First problem here. It says, in the figure to the right, y is 2 bigger than 3. Okay, so let's go ahead and write this down. Well, let's go ahead and see. If you see, it's kind of hard to see, but if we could kind of flip this problem on its side, we see that angle 1 right here is an exterior angle to angle 3 and 4. Okay, why is this important? Well, this is important because now we know that angle 1 is greater than angle 3, right? That's according to our very first corollary. The exterior angle is going to be bigger than a remote interior angle by itself, because 3 plus 4 should equal angle 1. So we know that angle 1 is bigger than angle 3. Well, how does this help us? Well, the reason why this helps us is because look at what kind of triangle we have, BBC. It's an isosceles triangle. That means 1 and 2 are congruent angles. So all we have to do is substitute 1 with 2. So angle 2 is the same value as angle 1. So we pull a little substitution here. So we did a little sub, and we flipped angle 1 to angle 2, And now we can prove that 2 is bigger than angle 3. So kind of tricksies what we did here. Alright, let's move to our next problem. Again, 4 problems today, 4 theorems, but we can go through them quickly. Alright, write down the problem. A town park is triangular, so we got this cool triangular park. A landscape wants to place a bench at the corner, so that's one of the vertices. So that's our key word, a corner right there. So we're talking about a vertice with the largest angle. Which street forms the corner of the largest angle? Well, we just got to look at our lengths. We got 105, 120, boom. 175 is our largest. Remember my hand, okay? The further apart my fingertips are, what do you notice about the opposite angle? Look at that angle right down here. It gets bigger. If it gets closer, the angle gets smaller. So what is happening? Well, our largest angle, our corner that we want to pick, which two streets form the corner with the largest angle? It's going to be MLK Boulevard. I believe we can shorthand Boulevard for that. And it's going to be in between MLK and Valley Road. So there is where it's going to be, and that's using that idea of opposite large side is going to be opposite the large angle. Okay, working our way through. 2 down, 2 to go. Here we go. Oh, feeling good. Feeling great. Here we are. Which choice shows the sides of TUV in order from shortest to longest? Okay, well here's what we got. We got all these segments. The first thing I want to do is I want to go ahead and I'm going to use orange. I'm going to try and match them. 58, 62. I got my calculator. I'm ready to go. I'm going to go ahead and calculate this. 58. My dog's wanting to be in the video over here. 58 plus 62. Okay, we get 120. Obviously, what's left to get to 180? It's going to be 60. So we get 60 right up here. Okay, 60 degrees. Now again, larger the angle, larger the opposite side. So, which is the largest side? Alright, well, let's go ahead and mark it. We're going to go like red is the hot, then yellow is medium, and then blue is cold. How about that? So largest side, red. Across from the 62, this side's hot. Okay? Then we start cooling down a little bit. Opposite 60, it's starting to cool down, yellow. And ice cold. Ice cold, we got blue over here, which is, actually, isn't blue really, really hot? Let me think about that. Let's not do like an ice cold blue, like a sky blue. This is our shortest side, okay? So this is the longest, middle, and shortest side here. And we're using those opposite sides, so let's go ahead and match that. UT, we want to go from shortest to longest, so we actually want to start with TV in the front. Alright, so C's out of here, B is out of here, TV, TV, the next should be UV, boom, it's got to be A right there. Okay? So again, using that same kind of principle, it's pretty cool. Alright, moving on, last problem here. Here we go, using the triangle inequality theorem. Boom, can we have a triangle with these given lengths? Here we go, this is what we do, this is the secret. You take the two smaller and you see if they add up to be bigger than the third. So 3 plus 7, is that greater than 8? Let's see, 3 plus 7 is 10. Is 10 greater than 8? The answer is yes. Boom. Okay? Let's get another example of that. Make sure you write that down. Boom, boom, boom. Boom, boom, boom. Alright, here we go. 2 shorter is going to be 5 plus 5. Is that greater than 10? Okay, well, is 10 greater than 10? Not a triangle. Okay, so this is not a triangle. Even though they're congruent, they're not greater, so it's not a triangle. Alright, and last one, just for funsies, you don't even have to do this one anymore. Now we're just having fun. We're just doing math for fun at this point. Literally, we're just having fun. Can a triangle have sides 2, 6, and 9? Well, I'm thinking right now, probably take the 2 shorter. Is it bigger than 9? 2 plus 6 is 8. Is 8 bigger than 9? Not a triangle. Okay, so Joke's on you. Does not work. Okay? Alright, we'll see you guys later. Peace.